So we have got this question. It's on similar triangles. The question says, prove with reasons that triangle RTP is similar to triangle MTQ. Okay? Now, as I told you yesterday, when you get a question like this, you should not become nervous at all. Use the names of the triangles that you are given to prove that those two triangles are similar. Because the names of the triangles are based on the corresponding angles. Okay? So here, first identify the triangles in the diagram. So RTP, this is R, that's T, that's P. Okay? And then MTQ, we need a different color. MTQ, that will be MTQ. So we have got our two triangles. Now the good thing is that this line that is NR is parallel to MQ. Okay? And PQ is a transversal from your grade 8 and 9, geometry of straight lines. Okay? So if I want to carry on, it means the first thing that I have to write is to say, in triangle RTP and triangle MTQ, like that. That's how you start. Number one, I just have to prove that two pairs of corresponding angles are equal. The third pair is automatic. So let me start with the R and R, with this R here, which is this angle. It is related to angle M. Okay? So that's angle M. So what do you call those angles? Alternate. They are alternate because MR is also a transversal. It connects two lines that are parallel. So the first thing that I'll write here is to say angle R, but here I'm going to be more specific because I'm doing the RTP. So I'll call it PRT is equal to, I've got MTQ, so that's MTQ. So I'll call this angle here, I'll call it TMQ. You can also call it QMT. So I'll call it TMQ. Then I'll write my reason, alternate angles. Then I have to state the lines that are parallel. Those two lines are MQ and PR, or you can put NR. It's the same thing. Okay, I'll put NR. If you put PR, it's also correct. Because point N, point P, and point R are collinear from your grade 10 analytical geometry. Okay? So I proved that a pair of angles are equal. Now I need a second pair. Again, I'll go back to the names of the triangle. Now this is more like you are doing grade 8 and 9 similar triangles. Only thing is that there's a little bit, this is actually a grade 8 or 9 question. Honestly speaking, it's actually grade 8 or 9. Okay? So if I move on to the second pair, we have got angle T. Now angle T in triangle RTP, it's this angle here. Okay? And then in triangle MTQ, you've got that angle, is that angle. What is the name given to those two angles?
Oh,
they are vertical opposite. They are vertical opposite.
Yes.
Please do me a favor. You need to go over your grade 8, 9, and 10 geometry. On the photo, I got some revision there for you to go. Okay? So I'm gonna say angle PTR is equal to angle MTQ. Okay, Okay, if you want, you can also call this angle T1, that one T2. It's your choice. Okay, then I'll write it in brackets here, vertical opposite angles. All angles that are vertically opposite to each other are equal. Once I prove that these two pairs, as I've done here, two pairs of angles, of corresponding angles are equal, I'm almost there. I'll tell you that I'm more than 90% done with the proof. Number 3, I can either say that the last two pairs are equal based on sum of angles in a triangle, or I can use geometry of straight lines. This angle here is equal to that angle. Okay, so I'm going to call this angle RPT. So I'll call it RPT.
So if the time is just say P.
It's not correct.
No.
You can't say P because there are two angles. How do you distinguish this angle and that angle?
Oh. But for R, you can say R.
Yes.
Okay.
But for P, you can't just say P. Either you can call it P1 or P2, but you have to indicate on the diagram. Okay? So I call this RPT. Then the other one, this one here, I can call it Q, but I'm going to call it MQT. It will be easier for a person to see. Now, there are two reasons that you can give here. Either you can write alternate angles, then you state the two lines that are parallel, that is MQ is parallel to NR, or you can say sum of angles in a triangle. Once you are done, then you say, therefore, triangle RTP is similar to triangle MTQ. And your reason, make sure you don't forget to write the reason. It's triple A, like this. Wait, let me use a different color. That's triple A. Okay, never forget to write this reason, because there are times when there is one mark for it. Never forget to write this, please. As long as I'm your maths teacher, don't forget to write. If you want, you can put the angle sign 3 times, angle, angle, angle. But I prefer to just write triple A. Whenever you prove that triangles are similar, this is the layout. This is the layout that I expect from all of you. Okay? Any question before I move on to the next? And here, I just want you to be aware that I wrote two reasons here. But you're supposed to write one. I wrote two because I'm the teacher. Right? Either you write sum of angles in a triangle if you are lazy to write that they are alternate angles. If you see that they are alternate, then you must take the lines that are parallel. Don't forget them. Okay? Any questions?
So how many marks is that?
Generally, this is about 4 marks. Generally, 4. It can be 3, 4, maybe sometimes 5, but generally it's about 4. 3, 4. To do everything that I just did here. Okay? And in your match control test, you have to do this. Alright. The next question. It's still the same diagram. Okay? Still the same diagram. There are many questions from that diagram. 1.5 says determine the length of RT over TM. RT over TM. Right? For us to carry on, I need the information from the previous question. Okay? So we're told that MN is 24 units and TP is 9 units. Then we had some ratios that we calculated, right? Like the ratio of RT over RM and RP over RN. I need those ratios. So I'm going to add them on the diagram. So RT over RM, okay? RT over RM right? I'm going to say my TR is 3x and my MT is 5x. Okay? Then so NP, I'm going to call it 5y, so that's 5y. And this will be 3y. Okay? And that's coming from the proportion theorem. Okay? And please be aware that it's up to there, like that. Alright? Then let's answer that question 1.5. It's RT over TM. So where is RT? RT is from here to there, and TM, that's T to M. Right? Now, you can see that it's very straightforward. Okay? But now we have to give a reason as to why we say RT over TM is equal to 3 over 5. Now, where does that come from? Well, it comes from here. Because I got here RT over Rm is 3 over 8. It's here. This is RP over Rm. Then I calculated RT over Rm. That was based on the proportion theory. Okay? That was based on the proportion theory. So my suggestion here is to use, okay, initially when we got Rp over Rn, we got it as 3 over 8. Then from the proportion theorem, we can determine that. So my suggestion is let's say in triangle RMN, if we use the proportion theorem in that triangle, we are going to end up getting RT over TM is equal to PR over PN. Okay, then you write the reason here, line parallel to one side of triangle. Okay, you could do that. Then from there, our RT over TM will be equal to PR, that's 3y. Then PN is 5y. So the ratio is going to be 3 over 5. Okay, that's my suggestion. If you want, you can go by similar triangle, but it will be more complicated. Then 1.61, the ratio of NP over PR. Okay, NP over PR, I already have this. Okay, so it will be the same thing. Now, so this is 1.5. So 1.6, I'm just going to write the answer because we've done the calculation. NP over PR. Now, you need to be aware that NP over PR, we can write this using this ratio. If it's NP over PR, then you can switch these two and write this TM over RT. You agree with me on that? You just switch them around. Then, our reason here, we can put the proportion theorem, because it's very important for you to write your reason. All right, line parallel to one side of triangle. Therefore, let me use a different color because I don't want to start in this way. So therefore, the ratio of NP over PR, NP over PR is going to be NP over PR is going to be equal to 5y over 3y, which will be 5 over what? Okay. Once you put your values in the diagram, it makes things very, very easy. Okay, the question will become very easy. Any question? Don't get a question, then let's move on. So therefore, this will be NP over PR. NP over PR. Okay, let me write it here. Therefore, NP over PR is equal to 5y over 3y. And that will give you 5 over 3. So once you put your values on the diagram based on the ratios together with the constant, it becomes easy. Okay? Then determine the ratio of area of RTP over MTQ. Okay? It's now RTP over MTQ. Those two triangles, we have proved already that they are similar triangles, remember? You agree with me?
Yes.
So it means that the ratios of their corresponding sides are what?
Yes.
Are equal. The ratios of their corresponding sides are equal first. Okay? Then from those ratios now, we identify the information we have that can help us to square the ratio and then get the ratio of the area. So what I'm going to start from by saying, from there now, I'm going to start by saying, we've got RTP, so I'll say RT over MT is equal to TP over TQ. This is equal to RP over MQ. Why is this true? It's based on similar triangles. Okay? Because already I proved that those two triangles are similar. Then from there, now I have to look at whether do I have any of the lengths that are in this ratio. Do I know the length? Let's do it one by one. Do I know the length of RT? I know.
Yes, 3.
Remember, this was 3x, and this is 5x. So I know what RT and I know MT. Which means that I'm almost done. Right? Yes. I just have to divide those two and square their what? Their ratio. Then I'm done. Right? So I know this one. I know I can find this one in RT over what? MT. This one here. I can use that. I can use that. So I'll write the area of triangle RTP over the area of triangle MTQ is equal to, is going to be equal to RT over MT squared. And this will be equal to, my RT is 3x, my MT is 5x. Then you square this. You will get 9x squared over 25x squared. Fortunately, the x squared and the x squared cancel, so the final answer will be 9 over 25.
So you will simplify out.
No, you can't simplify 9 over 25.
No, like
No, that's not important. Here, we are trying to find the ratio of those two, of the area of those two triangles. So you stop here, 9 over what? 25. The answer must be a ratio. Yes?
So you cannot use the formula of half 195 times.
No, it's not necessary. At this stage, it's no longer necessary. But if you want, you can try to use it. But the problem now is, if you look at the size of the triangles, we only know the length of RT in terms of x, the length of MT in terms of x. Do we know the length of TP? We know it, it's 9, so it's given. We know TP. Do we know TQ? TQ, we don't know. Okay? RP, do we know RP? Yes, we know in terms of y. It's equal to what? 3y. We know RP. MQ, do we know MQ? We don't know. So, it means that you probably have to calculate, if you know any one of these two, you can use them together with this ratio here to calculate it, if you want. That could be a long method. But if you understood the fact that if you want to determine the ratio of the areas of triangles, if you know the ratio of any two corresponding sides, you just square that ratio, you get the ratio of the areas, and then you are done. Otherwise, you have to use this ratio, then you find one of these two or you find one of these two. Then you substitute into the formula that you're talking about, the area group. Because they share a common angle. See this angle here, it's equal to that. So you can use the area rule. But you need to know the length of T cube first for you to be able to do it. Okay? Are you following? Alright. Any questions before I get on? If you have a question then I'm done with that exercise. So that will be the end of that exercise.
Oh.